Hi everyone.
My name is Dorian and my call sign is KM6QHU,
I'm Andrea. My call sign is KM6QHK.
and this is our video for our EE123 final project.
We'll be showing you how we compress and transmitted images via radio, including algorithms and different approaches we used, what worked and didn't work, and finally we'll show you our results.
On the compression side of things, we decided to use something similar to JPEG compression. Kind of the basic idea is that we split the image into 8x8 blocks. Following that, we take the discrete cosine transform of each of those blocks, and then we quantize all of those values using a special quantization matrix that we generate using a specified quality parameter. Once we actually quantize that data and kind of downsample what the dimensionality of the data is, we finally compress into an 8-bit integer, and then we apply entropy encoding.
For the transmission side of things, on the transmitter side, we use beginning and end packets to mark the start and end of transmission. We use AFSK 1200 that modulates the data into packets, which we put into queues and then transmit from there. On the receiver side of things, we listen for packets received as compressed data, we decode them, and then we reconstruct them into an image. Now for what worked and didn't work. We ended up using AFSK 1200 modulation to transmit our packets. We tried doubling the bitrate to 2400, but it didn't end up working. We were able to transmit 7500 bytes across the room. On the hardware side of things, we did have a lot of bugs. We ended up having to replace some hardware, resolder some hardware, but in the end it all worked out.
In this project, we originally started out trying to use the wavelet transform in JPEG 2000 in order to try compressing our images. In our actual specific situation, we found that we actually have to compress very, very large images into 7,500 bytes. And we kind of found that when we did that big of a compression ratio using the wavelet transform, we actually found that our images were very, very blurry. And we thought that having more sharp images with slightly more noise was more visually pleasing than these very blurred images.
So the image has just been compressed and the packets are ready to transmit. So here we go. So the image has just finished transmitting. It did it in 70 seconds. And let's see. Packets received.
You can see all the APRS packets that we received. You can see all those binary values that are transmitted. We received a total of 33 packets. You can see the end transmission packet, and then this is the output image we received. These are our live demo results. We were able to reconstruct both images in the requisite 75 seconds. On the left-hand side, you can see the binary EE123 ROX image. We got a PSNR of infinity because we got perfect reconstruction. On the right-hand side, you can see that we got a PSNR of about 19.5 for the midterm picture.